Okay, so we're now going to finish up unit one here, which is unit 1.6. So this is now unit 1.6. This is solvent investment portfolio problems on page 58. All right, so this is the end of it. Now, before we keep going here, I would quickly want to talk about what is a portfolio. Now, a portfolio, you've seen this term before, is a collection of things. If you're an artist, you might have an art portfolio. If you're a tattoo artist, you would have a portfolio showing that. If you're a teacher, you even have a portfolio. It's a collection of things. When we're looking at it in a money aspect, though, this is investments that are held. For example, maybe you don't, an example portfolio, maybe I don't know, maybe I have $10,000 invested in a bond. Maybe I have $2,000 in crypto. Maybe I put $200 in saving account every 2 weeks. And so on and so forth, right? It's a collection of investments that you might have. These are just examples here, okay? So so that's kind of where we are at here. So I'm gonna kind of shy away from the textbook here for one of these. But it's really just basically at the end of the day, what it's gonna be is, hey, here's this person's list of investments. What are they gonna be worth in 5 or 10 or 15 years? It's that simple. At its simple concept, what this entire unit is about, and you don't have to write this down, is um, what is the future value of current investments, right? That's all this unit is. It's just a bunch of math to do it out. It's nothing new than what we've done. It's just adding up. Frankly, it's just adding up the stuff we've kind of done up here. Is really what it is. So, um, what I'm going to do is I'm going to give you an example here. So I'm going to give you example. We have a portfolio that is 15 years old. What is the current value? And I'm just going to have two. So we have number one, what we have quarterly deposits of $300, sorry, $350 into an account earning 4.25% compounded interest quarterly. Okay. And then our second thing in our portfolio is I dumped $15,000 into a savings account or an investment or whatever it is, earning 4.0%, so 4% interest compounded annually. So those are examples here. So what is the current value of the portfolio, right? Because this happened 15 years ago. So that's what we're doing. We're trying to find the current value of it. Now you can either use your calculator or you can use your or you can use your website or whatever you want. But this is the exact same stuff that we did in 1.5, right? So we know what I actually want you to do. I want you to actually try and solve at least one of these, ideally both of these. Pause the video, see if you can do it with the tools you have from section 1.5, right? And again, those websites are on that stuff here is on. Oh no, it is here. So try that out. I'm pausing the video, and when you come back, I will go through it. Okay, so once you've done that, what I've done here, just to save us some time, I've kind of streamlined this here a little bit. So I've done it one on the calculator and two on the website. So on the website, so here's number one, right? Investment one, the quarterly deposit of $350. So you can see I put this in here, blah, blah, blah. I put it all in. This was the thing that I had to press the FV for to solve as a quick refresher. Again, your interest rate is always going to be annual. It's a 4.25 yearly percent interest rate. It's just calculated quarterly. Where did you get 60 from, Mr. Waskowski? Great question. It's 15 years and it's done quarterly, right? 15 times 4, it's compounded for a total of 60 instances, 60 periods. So that's where that comes from. So that's investment one. Investment two, same thing here, right? 4% compounded annually, annual, blah, 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 blah. This is our amount here, right? So here's our amounts. If you want to see how I did on the calculator, read from left to right in this case. So again, compounded 60 times, 4.25. Payment, keep a note, negative 350, not regular 350, not positive 350, not subtract sign 350, negative 350. Okay. Again, 4 and 4. And in question 2 here, same thing here that we get. So we end up with the same answers here. So we know we are correct here. So long story short, investment one is worth, this is that quarterly one. What did I say it was? Here we go. $29,165.93. Investment two is $27,014.15. So combined, those should equal up to 27,014.15. 56,000, right? So 1 plus 2, investment 1, investment 2, $56,180.08 is the total investment value after 15 years. Right? So here we go. So this is it. So simple enough, right? So simple enough. That's what this unit is. It's taking this stuff up here and you're just doing a couple of them. So as you can see, organization is going to be pretty huge for this. Now, you don't need to necessarily show all your work in this regard. I don't want you just to chuck in an answer because you're going to come back 4 months from now. You're not going to have a freaking clue what you did. So you need to actually go in and you need to, write down like this basic stuff, right? And here's the interest, here's the present value, here's the payments. You need to write that crap in there, okay? So make sure you're doing that. All right. So do I want to? So you should be able to do example 1. So try that out. Pause the video, try out example 1, then check the answer down below. So 3, 2, 1. So you should have gotten for question A, about this. You might be off by a couple cents. If you're off by $1, that's not a big deal. But you should be around there, okay? And same thing, rule 72. For example 2 here, 6 years, cost of a new laser. He can save $50 a month. We can skip this one here. We're not going to do some current research on this. That is a financial literacy option. What we are, however, going to go do is we are going to go do example 3 here. So I'm going to use a new page for this. So this is example 3 on page 62. So let's really look at this here. So what we have is we have Jason. We have Jason's portfolio and Malik's portfolio. So they each hoping to buy a house in 10 years. They have different portfolios. They're trying to invest their money so it can grow, so they can use it as a down payment, right? In 10 years, whose portfolio will have the greatest return on investment? Okay, so the greatest return. This might not be necessarily who has the most money. If I invest $1,000 and I get a return of $3,000, that's $2,000 of a return, right? If you invest $2,500, you get $3,000 back. Your return was only $500. So we want to look at who had the best rate of their return, right? Who made that like as a ratio almost. So think about it this way. Jason's portfolio is 1, 2, and 3, right? Malik's portfolio is 1, 2, and 3, right? So you just got to add up just how we did up here. We had 2 investments. We added it up. You're doing the same thing, but it's 1, 2, 3. Then you're doing the same thing for Malik. 1, 2, 3, and then you're comparing the two of them. Okay. So what I'm going to get you guys to do here is I am going to get you to try out solving 1, 2, 3, 1, 2, 3, and then we'll talk about the comparison in a bit. So pause your video, do your best. If you get it wrong, doesn't matter. You're practicing. This is a time to practice it. So pause the video. I'm going to come back. When you come back, I'm going to go over the answers here. Okay, so welcome back. So what I've done here is I've done the calculations here for you. I've only put the examples of the calculators and the online calculator here for the first example. And you know, again, I'm using these numbers here to kind of represent space. This is showing your work. By doing this, you show your work. Another thing I want to note, you might have had issues. These numbers on your calculator need to be the same. It just breaks your calculator. Some of you might have experienced that error already. But anyways, point being, investment one, 10-year, $2,000, 4.2% compounded semi-annually, $3,330.71. So Jason won. J1 is that. J2, here's my figures here. $31,000, $329.72, right? 55 bucks a week, every single week, compounded weekly. J3, $4,856.65. Yada, 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 yada. Now, here's a really common mistake people will make. He invested this amount directly into another bond, which gave this much, right? Read the question carefully. It's a 10-year investment. Bonds are 5 years, so he did two of them. So if you add all of these up, first off, we got to figure out how much did he invest? Well, he invested $2,000 in J1. He did $52. Sorry. Did I goof up? He did $55. 55 times 52 times 10. Sorry, 1 second. Yeah, there we go. Okay, that fixes it. So you did $55 a week for 10 years, right? So that's why I have this here. You could just put a blank number if you want. Like you could just put the actual number, but I'm doing this to show my work. And then $4,000 for J3. And then this is how much he invested. How much did he earn? Well, I added up all three of these numbers, right? Boom, boom, boom. He earned $40,315. So how much did he profit? About $5,700. Now, Monique, you know, here's my work here. Her first investment was 69, almost 7,000. Her second one was almost 5,900. Her third one was 26,000, right? So she invested the exact same amount as him. If you're really paying attention here, they invested the same amount. We know how much she earned. So the question here asks us, after 10 years, whose portfolio will have the greatest value of or greatest rate of return? Well, right now, to the question, the answer here, simply put, because they both invested the same amount, Jason, whose portfolio earned more, gained more, or earned more, had a better rate of return. So that's the answer there. But now don't exit out the video because I have a very important question for you. What if their investment amounts were different? Who do you figure out then had the best rate of return? Again, and as a reminder, a rate of return, if I invest $1,000 and I profit $2,000, whereas you invest $1,700 and profit $2,000, I had the better investment. I got more bang for my buck, right? I turned my $1 into $2. You turned your 170 into $2. I did better. I had a better rate of return. So what if the investment amounts are different? How do you solve it then? How do you answer this question? Because this question is not asking who had the most money. It is asking who had the greatest rate of return. So your textbook does a really good job of explaining this here, but your rate of return here, let me just scroll up on the right side. Again, to compare investments, you use this thing here, but generally speaking, how do you find out what the rate of a return is? What is the rate of a return? Basically, rate of return is equal to take your profit because that's what this is here, right? This is the earned, this is the invested. Take your profit, divide it by your investment. It's as simple as that, right? Take your profit, divide it by the investment. The higher rate of return is better. It's as simple as that. And your textbook, again, does a good job of this. If we look at it, so look at the left side now. So Jason's rate of return was 0.165, right? So for every dollar he invested, he got a dollar back. Sorry, he got 16.5%, right? So this is about 17%. So that's a better way. They turned this into a percentage. So Jason got 16.5% as profit. Malik, on the other hand, she only got 12.3% as a return. So Jason, ding, 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 Jason's the winner. Congratulations on the better investments, Jason. So key ideas here. So write those in, then pause the video. Pause the video, write those in. 3, 2, 1. All right, so key ideas here. So rate of return is a useful measure for comparing investment portfolios. You can build your investments from a bunch of different types of options. We don't really care about the options right now. Right now, we're just doing the mathematical component of it. Investments that involve greater principal amounts invested or greater regular payments amounts when contracted tend to offer higher interest rates. It's not a rule, but it's a common trend. The biggest things that contribute to investment are time, interest rate, and compounding frequency. You want to know what your credit card is? Your credit card is probably 20 or 20.9%, 99% interest rate. It's compounded daily. And over time, sad face. Doesn't work out well for you. Okay. So that's it. That is unit 1.1. Sorry, it's unit 1. So to finish, so if your work here, 1.6 in the workbook, 1.6 in the textbook, 1.6 assignment, and your 1.6 test. Oh, sorry, unit 1 test. Okay. Awesome. Good work, guys.